Hello student, in previous lecture we see about the modern periodic law and structure of modern periodic table. Today we see about the electronic configuration of an element. So before starting our topic, if you like my video then please like, share and subscribe to my channel. My channel name is Sharda Survase. So now we start our topic, that is the electronic configuration of elements. So firstly you understand the meaning of electronic configuration. Basically we know that in an atom at the nucleus, in the nucleus of an atom there are protons and neutrons are present, and around it the electrons are revolving in a different orbit. So where is the exactly position of electron? Means suppose the atomic number of element is 10 at that time in first orbit and second orbit, how many exactly electrons are present, and this arrangement of electrons present in a orbit, different orbits and shells in an atom, it is called its electronic configuration. Electronic configuration means arrangement of electrons in the atom. Okay, electronic configuration means arrangement of electrons, arrangement of electrons in the atom. In an atom it is called as the electronic configuration. Okay, so today we discuss about the electronic configuration of different elements. Means in the periodic table total 118 elements are present. Their electronic configuration is also different, and according to their electronic configuration and their atomic number, the properties of element is varies different. Basically in the periods when we going along the same periods, basically in period first hydrogen and helium are present, in period second means lithium and beryllium are present. This shows the slightly different in their properties and sometimes more different properties. It depends on their position. Means the element present in the same period which is nearest to the element, they shows the similar properties, and some are very distant from each other, like the sodium and argon, sodium and sulfur are present in the same period, but their distance in between the two groups and the period is very large. That time it shows the largely difference in their properties. But the elements present in the same group, like the first group, that is the hydrogen, lithium, sodium, potassium are present, they shows the same property and also same chemical properties also, and also shows the same gradations. Gradation means their series or their different grades according to this property. These are similar along the groups, but along the periods it shows the differ in their property, and this phenomenon it is called as the electronic configuration. And with the help of electronic configuration we can find the exactly position of an element in the periodic table according to their electronic configuration. So firstly today we learn about the groups and electronic configuration. When we study the elements according to their groups in the same groups, that time what exactly changes in happening in their electronic configuration and how they vary the electronic configuration of an elements. So our today's topic is groups and electronic configuration. Means we learn the electronic configuration of elements with along the groups. Hence today's topic is our groups and electronic configuration. Okay, groups and electronic configuration, EC, groups and electronic. Suppose the first group, okay, in first group which elements are present? Hydrogen, lithium, sodium and potassium, and also rubidium and cesium are also present, but we only take a list of small elements, that is the hydrogen, lithium, sodium, potassium. The atomic number of hydrogen is 1, lithium is 3, sodium is 11 and potassium is 19. Okay, that time the valency of first group elements are same, their valency is first. Why it's first? Valency, it is nothing but the combining capacity of an element to the other element. It is called as the valency of that particular element. So valency, the first group element shows the valency is first. Why it shows the first or 1? Not, it is not first, it is the 1. Valency is a 1. Why it shows the valency? Valency, basically we already seen in our previous lecture. So today I also recall to you one definition of valency. Valency means the combining capacity of an element to other element. It is called as the valency. Valency, it is nothing but the combining capacity of an element to the other element. It is called as the valency. Suppose the first group elements are hydrogen, lithium, sodium, potassium. The atomic number of hydrogen is 1. So it required one electron to complete its octet. Basically, the structure of hydrogen is like this. Okay, one electron is present around this. But in the first orbit in the around the nucleus, it having the capacity of 2 electron, but here only the 1 electron. So basically hydrogen donates its 1 electron and become a H plus hydride ion. So the valency of hydrogen is 1. Then lithium का structure कैसा आएगा? This is the nucleus. Along the nucleus, one orbit is present, 2 electrons, again 1 electron is present. So it basically donated outermost electron is 1 to the other element and react with other element. So their valency of lithium is also 1. Then sodium, the structure of sodium element is, that is the nucleus. In the nucleus, protons and neutrons are present, along with orbits are present, different and different orbits. These are the different and different orbits of sodium element. So here 2 electrons are present. This is the capacity of 2 electron, this orbit. Second orbit having the electronic capacity is 8 electron. 2, 3, 4, 5, 6, 7 and 8. How many electrons are total? 8 and 2, 10. 1 electron. So 1 electron present in their outermost orbit. So basically sodium atom or sodium element also donate their outermost electron and become their valencies become 1, because for to combine with the other element it donates it 1 electron, hence the valency of sodium and it acquired the electronic configuration like the noble gas argon, and hence sorry, not argon, it is neon, 10, atomic number is a 10, and acquired the electronic configuration of neon. Okay, so so it is the structure of sodium atom, and hence the valency of sodium atom is 1. Means the first group element, that is it varies from the groups, it shows the similar in their properties. So it is the first example of first series. It is called as the alkali series or alkaline metals. Okay, so it regarding to the first group only. Let us study about the second group. When we see about the second group elements, in second group elements, which are the second group elements? Beryllium, magnesium, calcium and strontium. So second group elements, when we think about the second group elements, that is the beryllium, magnesium, calcium. So beryllium is having the atomic number 4. Then again magnesium 12 and calcium is a 20. Okay, it is also present in the same group. It also shows the same property. Their electronic configuration is like this. Beryllium, center at the nucleus, along with the 2 orbits are there. So 2 electrons are present in the first orbit. In second orbit also 2 electrons are present. So basically it also donates this outermost 2 electrons and the valency become 2. Valency of beryllium become 2, and hence the valency of these all the second group elements is 2, because they shows the same property. And this second group element, it is called as alkaline earth metal. Okay, alkaline earth metal. They donate, means valency is nothing but the combining capacity of an element to the other element. That time sometimes they take the electron and sometimes they donate the electron according to their electronic configuration. In first group elements and second group elements, they having the some extra electrons are there. So basically it donate their extra electron and become their valency become first group element is having 1 valency and second group element is having the 2 valency. Similarly, when we think about the halogen groups are nothing but the 17 group elements. 17 group elements 17 group elements, which are the fluorine, chlorine, bromine and iodine. Their atomic number is a 9. The chlorine atomic number is a 30, not 35 it is. The chlorine having the atomic number 17. So their electronic configuration of fluorine is, they are having the, this is the nucleus, first orbit and second orbit. So in first orbit 2 electrons are there, and in second orbit how many electrons are there? 7. 1, 2, 3, 4, 5, 6, 7. Total 7, 8 and 9. So for to complete it octets, it required how many electrons? It required 1 electron to complete their orbits or fulfill their orbits. Hence it basically take 1 electron, sometimes taken from the hydrogen, sometimes taken from the sodium. Means all the first group elements easily react with the 17 group elements, that is the halogen, fluorine, chlorine, bromine and iodine. So these all the elements present in the 17 group shows the similar property, and hence it is called as the halogen family. It is indicated by the word halogen families. It is called as the alkali metals. Their valency is first, because first valency, why it is valency is 1, because it easily donate their outermost 1 electron and become a stable, so and react with the halogens or other metals. So it is called as the alkali metals. Their valency is 1. Then second group element, their valency is 2. It is called as alkaline earth metals. Alkaline earth metals. Their valency is 2. All the elements present in the second group, they shows the similar property. Basically, the property means the elements present in the same group, they show the similar property, but the elements present in the same period, they are that time their property is not same. They varies, because when the element present near to each other, that time they show the some similar property, but they varies, the distance between the two elements is very large, that time their properties are also very different from each other. So this is the about the electronic configuration and properties of elements along the groups we see in today's lecture. And we also learn about the one basic concept, that is the valency of an element, how we can calculate the valency. It is depends upon the stable electronic configuration. So today we stop here. In next lecture period we see about the periods and electronic configuration of elements. Means we see the electronic configuration of elements along their periods. Today we see the electronic configuration of elements along their groups. It is similar. Their valency is also similar, but depends upon their electronic configuration. They indicate their which groups are they are present in which groups, and according to that groups they find their valency also. So today we stop here. Thank you.